Welcome to our first afternoon session. This is Mr. Rick Heaney from IBM Global Business Services. On stage with me, I'm Constantin von Altrock, representing the IBM Safer Payments offering, and I'm their CTO. Some of you may have seen me yesterday failing to explain how we prevent fraud in real-time payments in 15 minutes. I'll take some 20 more minutes now to give some of the details of what I was skipping about yesterday. So I was talking about 5 lessons that we have learned in preventing fraud with real-time payments. These were use peer profiling, use cross-channel profiling, use additional data sources, join the data science revolution, and apply the principles of Agile. And I have briefly explained them, but I want to go in some more detail to give you an idea of what it is. So let me start with peer profiling. I already mentioned that peer profiling is that whenever we have a transaction and an originator and a beneficiary, we are not only profiling the originator also in his past role as an originator of other transactions. So we know what kind of behavior he has, and the recipient in his role, in his behavior as a recipient of other transactions. And also the opposite, we are profiling the originator as a recipient in the past and the recipient as an originator in the past. So what that provides us with is 4 historical dimensions that describe behavior. And that helps us with the situation that real-time payments, we don't have the rich data set that you have with cards, where you have, for example, the merchant category code, which tells you what type of transaction it is. So we sort of produce new data out of the little data that we have. And the little data that we typically have in real-time payments is a high frequency of payments. So there is a lot of past that we can profile. Now, what can we do with that? It starts very simple. It allows us to detect mule behavior of accounts in real time. We analyze what transactions come into an account within a certain time period, what goes out of it, and that then allows us to build rules like within the past X hours, total of deposited transactions was within a certain percentage of the total amount withdrawn, which would be typical behavior of a mule account. So we can understand when an account that we are monitoring all of a sudden has this typical behavior. At the same time, we're looking into all the relations between the originators and the beneficiaries. So we want to find out what kind of relations have they had in the past. Have they had transactions in the past? And if so, how is the current transaction relating to that? And even if parties haven't had any contact before, so for example, if I am sending money to a beneficiary that I've never sent money before, if other customers of the bank had sent money to these beneficiary before and over a long period of time and never fraud was there, then the likelihood that my transaction will turn out to be fraudulent is very low. So we can also use social intelligence here. By far, the most important application of peer profiling is to detect structuring and smurfing, which is a behavior well known within money laundering, where you disguise the true flow of money. And because in real-time payments, the flow of the money is the most important data you have to analyze potentially fraudulent behavior, it is absolutely key to reconstruct that. And let me give you a case study of one of our customers to exemplify how this has helped to protect from a very massive attack of fraud. So our customer in this case, the name is Kiwi, Q-I-W-I. It's also the NASDAQ stock symbol. So this is American money. They're licensed, they're registered in Cyprus, so they call themselves a European company, but their operations are in Chertanovskaya, which is a suburb south of Moscow, and they are the dominant real-time payment system in Eastern Europe. And Eastern Europe, most of the economies are cash-based economies, so it is still normal that employees get their monthly or bi-weekly pay in an envelope as banknotes. And because cashless is important for many things, Kiwi has 200,000 of these ATMs, mostly for cash in, and many Eastern European citizens just use, whenever they get the money, these machines to, first up, charge up their accounts. So they have 200,000 of these machines everywhere, at bus stations, supermarket, outside, indoor, everywhere. Then they have a system of mobile wallets, can be accessed from a browser, mostly through an application on a mobile phone. And it is used for peer-to-peer payment transactions. It is used for POS payment transactions and for e-commerce payment transactions. They have about 75 million active users. And some of these user accounts, about 20 million of them, have Visa card identities associated to them, either virtual or as plastic. So here you see 3 lines of business, which are a perfect ecosystem of an almost closed-loop real-time payment system. It is very convenient for users, and it's also very attractive for criminals. That's why we had installed Safer Payments in 2013 with them. And 2 months after we installed it, Russia had been the target of a new type of crime attack that has never happened before. And that was using fake banknotes. So you might say, what's new about fake banknotes? Well, what's new about it is that they're easy to see, to identify as falsified. So even I, not being an expert in that, they have shown me one of those fake notes, and I compared it to a real one. It was pretty clear that they were different. Because for the first time, criminals have fake banknotes not to fool the human eye, but to fool the machine. Because all these ATMs have the same, not just of Kiwi, but of all the banks have the same kind of cash scanners for cash in ATMs. So they have optimized the banknotes to trick the machine. In hindsight, it's perfectly clear, but nobody had expected that before. And obviously, these notes were produced in a very large volume because the entire market was flooded, mainly with the 5,000 ruble bills, which is sort of the most common denomination there is, about $30. And what happened is that basically, for many weeks, most of the financial institutions that were accepting money through ATMs had to close down because they just couldn't deal with the amount of fraud anymore. Now, what we have done is, because we were able to use our peer profiling, we were able to see how the money was flowing through the network. So we have seen that the gangs were only using certain ATMs. When they have used them, they have used relatively large amounts of the same denomination, and they have charged up a number of accounts. And then they have moved the money to mule accounts, and from these mule accounts, then they have tried to take out money through ATMs. And because we could clearly see how the money was flowing through the network, we could stop it at the last moment. We didn't have to stop it before, because as long as it was moved around within those accounts, it wasn't leaving the system, so there wasn't any damage. We could stop it at the latest point when we were seeing the entire flow of money, and we could be relatively sure that this is actually a fraud case. So as a result of that, our customer was able to keep their business open because they could accept all the banknotes, because before the illegal funds were taken out of the system, this could have been stopped. There is a presentation that I've done together with the customer on that from a while ago. The video is after this link here. So the challenge to do that is not the actual computation of this. The actual algorithm isn't that complicated, but because of the complexity here, which has combinatorial elements, computing this in real time is the challenge. So it has taken us quite a bit of work to get this done in real time, because only if it's done in, these things happen very fast, only if it's done in real time we can actually prevent fraud. And we have to do this with thousands of transactions being processed per second, because there is a total of 9 billion financial transactions in this network. Okay, so much for peer profiling. Cross-channel profiling. Yesterday in my keynote, I already talked about 2 examples how you're using cross-channel profiling to help to reduce your false positive rates. So you would see a transaction from a UK banking customer with a UK address, all of a sudden initiating an online banking real-time payment from a Malaysian IP address to a Malaysian beneficiary, and he's never done that before. That's high risk. Everybody would decline that. But if you see from cross-profiling behavior in the other channels that there were legitimate transactions done in the same regions, then you can exonerate it, and you can avoid a false positive and authorize that transaction. At the same time, I quickly talked about it yesterday, when organized crime hits, and sometimes we are calling them well-organized crime when we see how careful they execute their attacks, then they're not after small amounts. They're after many millions, typically. And to get this kind of money out of a bank and not be caught usually means that they're moving the money first into another channel and then funnel it out of the bank. And if you don't have cross-channel profiling, it's just much, much harder to securely detect that. Now, to some of our banking customers, when I talk to them about cross-channel profiling, they're getting a bit scared because they say we're just doing siloed fraud prevention is hard enough. So just a quick remark. Many of our banking customers are using the advent of real-time payments to start a payments modernization program for the fraud prevention part. So typically, our customers have established lines of business. These could be credit card, debit cards, or it could be digital channels. And as fraud hit these payment instruments, they have deployed fraud prevention systems. And they're usually different ones because that was done at different times and different solutions were better. Sometimes they exchange alerts, but they definitely, in the rarest cases, do fully profile transactions from the other channels. So now the new thing comes around, real-time payments. And what do you do about that? So the approach that many of our customers are taking is one where they have small steps, where each step provides a very tangible benefit. So the first step is they just install a cross-channel profiling system in a central location, and they just connect it to real-time payments. So that's not very exciting because you've just added another siloed solution, but that's only the first step. Because once you have that, you can feed data from all the other channels in here, and you improve the quality of your decisions down here. Higher detection rates, lower false positives. And because you're seeing cross-profile movement here, you can also generate additional alerts into the various payment instruments here, or override alerts to avoid false positives. And some of our customers eventually at some point want to replace the siloed fraud prevention systems. Others intend to keep them. But the benefit of that is you don't have to make a decision now, and you can do this at any point in time. Number 3, use additional data sources. And the data scientist mantra is data is good, so more data is better. And that's true for the most parts. And let me use the example of digital channels, online and mobile banking here. So you have a customer with a device which is talking to a bank application which is residing in a bank's data center and hopefully connected to a fraud prevention system. Now, additional data sources, we already talked about multi-channel, cross-channel profiling before, are of course when you're feeding in financial and non-financial transactions from the other channels. But then there's also reference data, and reference data comes from any kind of a data lake database. It could be describing the customers. It could have certain reference data about the customer. But what we frequently also use is we use geographic databases for IP addresses or internet service providers and lists of known compromised computer systems or output nodes of anonymizer networks. What is very important is to have some kind of identity data in it, because any transaction which is done in the internet, you lose the physical connection to the customer. And the older ones of you may still remember this meme here of the 1993 on the internet. Nobody knows you are a dog. And so what can we do to find out something about our counterparty? So what we typically do with our customers, we install our identity SDK inside the bank's data center, which goes into the session with the customer to elicit certain additional information that is then also fed into safer payments. And there are typically two components to that. One is to track devices, and the other one is to track actually users. And tracking devices allows us to build a database of devices that we have seen from a customer before. And depending on previous use, we can more or less trust these devices as not being likely part of a fraud. Device profiling is the opposite here. We are profiling the behavior not of an account, but of devices themselves. And if we, for example, see that a device which has never been used before is now used with, for example, a dozen of otherwise unrelated accounts of your bank, then this is a high-risk indicator. And then, of course, device intelligence. So we elicit multiple pieces of information from the devices. So if we have a Canadian customer, but we find out that the browser language he's using is Mandarin, and the time zone of his computer is Shenzhen, then this could be a Chinese business person who just for convenience uses the settings of his country. But if your customer has never done that before, at least it gives reason for suspicion. And then it's also profiling the IP address, and in particular the internet service provider, because criminals have certain internet service providers that they favor, just because they're signed up with them or they have anonymous login or things like that. They're easy to trick. So what has become very successful is if we only see 2 or 3 transactions from a certain internet service provider per month, and then all of a sudden we see a flood of transactions from the same internet service provider, this is a very easy and clear indicator that something is going wrong. So the same thing also, not just for the device, but for the user, for the human which is behind that. We use biometrics to identify how somebody is actually using the device. So on a PC or notebook, it would be typing speed variances in that, or on a touch device, the agility of touch. And through that, we can also get certain additional data that helps us to have an understanding whether we should be suspicious that it's not the genuine user behind that. Also, typical user behavior. Are they copy and pasting the login and the password in, or are they typing it in? So there are certain things which tend to be very stable for most users, and it's not like we have to find out of a million users I have on my bank side, who is this person. That's not the problem we have to solve. The problem we have to solve is that you have one user who claims to be Mr. X, and we have to find out how plausible it is that this is the customer or this is the person who he pretends to be. So while this sounds like rocket science, identifying a person just from the way how he uses that PC, this is not the kind of application we're doing here. We have a hypothesis. The hypothesis is it Mr. X? And the experience is that we get pretty good in recognizing that. That was the wrong button. It's also filtering for artifacts. So when we see, for example, that the mouse movements are a little abrupt, that could be an indicator that somebody is controlling a remote session where you have this kind of behavior. And in the end, it's also session fingerprinting, which allows us to identify if pretty much the same session happens twice, because that, again, is another typical property of some kind of script which is replaying a session with just different payment parameters. So the next data element is session data. Some of our customers actually put each and every HTTPS request into safer payments because they want to understand the navigation, timing, and routing. How is somebody moving around on a website? And also from the way how the HTTPS requests are done, certain malware can easily identify it by their fingerprints. Now, what is important to notice is that everything I said so far runs within the bank's data center. And that is important because in the bank's data center, all these other data sources can be combined with the financial data. So it may be that you see all the high-risk factors that I talked about before, but the person just transfers money to an account that he has been transferring money to many times before over a long period of time. So the chances that this is fraud is fairly minimal. So the key to not just detect fraud, but also to keep the false positives low, is to always combine this with the financial data. And because banks never would give out their data into the cloud, must be using technology which completely runs in the data center. I'm highlighting this because there are also what we call threat intelligence services which sit outside the data center. And because they sit outside, they cannot combine whatever they're doing with financial data, but their position outside the data center allows them to do something else, because they can go in the internet, they can actively looking for risky behavior of customers. For example, if somebody is likely to give away his credentials and is subject to phishing. And also they can combine the data of one bank with the data of another, or with merchants. So if you want to find out if this person or Amazon thinks he has committed fraud with them, that is something that no solution which is within a bank's data center can do. Then you need something which is on the outside. Okay, join the data science revolution, our lesson number 4. And we all see the massive progress that machine learning and artificial intelligence in our days and ages is making. And fraud prevention has been a very traditional user of machine learning and is massively impacted by this development. And a lot of the progress, the scientific progress in that field, is actually supported and driven by open source tools or vendors that are not from the payment space. There's Google TensorFlow, there is Facebook has its own AI, and of course IBM Watson is there. Now, these have never been created to run payments 24/7 with 5.9 availability and with thousands of transactions per second. However, the new data scientists you may hire soon have been growing up with these tools and get good results with that. So this is why we have opened our transaction monitoring platform, Safer Payments, so that we can run any of these artificial intelligence generated models today and in the future, because whatever today may be the best machine learning technology is probably not in 3 years, and you don't want to change that platform. So I have to apologize for what happens when I click here now. Usually that's the moment when my marketing people in the room go like this and don't want to be recognized. But this is a functional chart of our fraud prevention offering. And if you look at these are just the major components. Then you may say, wow, that's an overkill. You cannot possibly need all these things to do payment fraud prevention. Yes, you do. And you need, what this down here is, this is, for example, the ingestion of data. So transformation, pre-processing, mapping, indexing, sequencing, merging, and replication in a clustered resilience environment, a dual-ported database that supports the real-time process and also virtual simulation for testing and development, all the analytical toolkits, a real-time decision engine, model lifetime management with all the governance, with all the testing, a model factory approach that allows you to combine multiple machine learning techniques, because it's rarely that one technique is good for everything. And then the various type of machine learning algorithms, and they're never used alone. They're always used in conjunction with decision rules. And you need all these things to be able to connect to open source tools and to the tools from any other vendor. And because we wanted to be sure that we don't inherit any instabilities from the open source part, the way we ingest these models is we take them as data files. So we're not taking in any code, we're just taking in the models. So our customers can use all the creativity of these tools here to generate models, but then when they import them to the payment fraud prevention platform, they run in this code, bulletproof, tried and tested, and with thousands of transactions per second. Running out of time, you already see that I'm getting quicker, same as yesterday. My last point, apply the principles of agile to modeling. And I explained yesterday that fraud prevention is highly dynamic, and the faster you can react to emerging fraud patterns, that immediately translates to savings. So speed is money in this case. The problem is that machine learning requires huge amounts of data. And while if you, for example, in other spaces, you can just use more, if for example, you're teaching cars to drive autonomously, you can use more cars to collect more data or let them drive longer distances. But in our space, you cannot just ask your customer for a week to make 100 times as many transactions as they usually do, and the criminals to make 100 times as much fraud as they usually do. So all you can do is to collect more data, is to wait. And waiting is bad. Waiting is costly, because your models outdate, catch less fraud, and have higher false positives. So this is why in our industry, typically, these machine learning risk score models are generated for the more stable fraud trends. And then you use decision rules by experts that determine on how these are applied to a specific type of transaction or to a specific situation. Now, that all of a sudden is a very manual process. And because it's a manual process, it's not overly efficient, and it also takes quite a bit of time. So we are using artificial intelligence not just to create these scoring models, but also to create the decision rules or to assist with the creation of these decision rules. This can be a very interactive process. Some of our customers prefer that the artificial intelligence only gives them suggestions, but they still like to steer it. It's rules, so it's not a black box model. Let me show you a quick example. This is our old UI. You just have to get that. It's a video that gets started, but it's in real time. So it looks at a number of attributes. Just a few are shown here for screen real estate. And it starts to suggest certain rules. So for example, here, it takes a certain interval of the score from 0.8 to 0.85. And it finds out that if it combines that with another criterion, the most occurrent MCC, so the merchant, this is cards, the example, so the merchant category code that was used most in the past 10 days, if this is one of those, and the last response code of the authorization system was one of these, then this rule will catch 20% of the fraud with a false positive rate of 0.97. And the second rule, similar, which goes on top of that. So this allows our customers to very quickly react to emerging fraud patterns. And on our last Safer Payments Roadshow, we had one of our customers speaking about their experience, Freddie Ramirez from WEX, medium-sized processing company in Portland, Maine. And he said that when they are under attack, his staff is doing multiple models per day, and his staff is just one person. So one person with this technology can adapt the model even multiple times per day, so they're always kept fresh with respect to fraud. Okay, so this is my second half-failed attempt to explain fraud prevention in a time which is way too short, and I hand it over to Rick.
Hopefully we can bring some of it together. So I look after risk and financial crimes in our center of competency at a worldwide level. So I get a chance to talk with and see banks and insurance organizations and others around the world. When I took this role over, they told me the hardest thing that I would have to do is to begin to thinking like a bad guy. And they're not wrong about that. And as I work with the banks, especially in payments areas and in the digital and marketing areas, they're all very eager to put capabilities on the street to make it easier for their customers. It also makes it easier for the bad guys, because most people don't think like bad guys. They don't think about how these things are going to be used against them until they are, and then it becomes a recovery exercise, not a planning exercise. So the reason we're at a payments conference talking to you about how to protect your digital channels is to help you start thinking a little bit more like bad guys. Hopefully you don't apply it, you just think about it. And that we can begin to help you think in advance how to defend and protect the channels, because really we're creating a golden era right now for the bad guys if we're not careful. So when you combine what y'all are looking at and doing from a payments modernization perspective with what's happening in the digital transformation of the digitization of the banks, this is creating this new gold rush for the bad guys. They can do things now that they couldn't do before because you're equipping them to. And so when you look at some of the things that Constantin's been talking to you about the last couple of days, how do we then begin to package these into not just payment fraud detection, but into things like account takeover attempts and the ability to create first-party bust-out fraud accounts within the banks. These are all going to be enabled by modernized rapid payments, and so if we don't think about them in advance, we're going to be in trouble. One large bank client that I worked with, who I consider to be best in class in the fraud area, was telling me that basically they're only catching about 50% or detecting about 50% of the fraud that's coming through their digital channels. And part of the problem is what they've been doing in the past is no longer relevant for the future. And now we have to rethink how we do some of these things. So when we think about digital transformation, to be honest, this is like robotic process automation for the bad guys. If I went and bought an identity off of the dark web, and I wanted to use it to commit fraud in the past, I would have to find a physical barrier. I'd have to get through a physical barrier. I'd have to take it to a branch and convince them I am who I say I am, or I'd have to use a point-of-sale device at some merchant. But there's going to be a level of effort for the bad guy to go through to validate that this identity is actually usable and that I can commit fraud with it. When I can open an account in under 30 seconds without ever seeing anybody through a digital transformation, I can now set up a bot. I can buy 5,000 identities for less than $5 a piece on the dark web, load up my bots, point them at all the banks in their digital, and all of a sudden now what used to take me days or weeks to go through, I can do literally in seconds and minutes. And so now we wonder, why is the fraud increasing? The payments modernization is the monetization of that. Because now if I can either open the account and put money into the account, I can quickly move money out of the account through real-time peer-to-peer payments. So when you couple these two things together, as I say, it creates the ability to do for their business what robotics process automation and AI is doing for years. The problem is that their business is profiting off of your business. So these are the things that we're starting to look at. In fact, I stole this chart from one of our payment experts, who I've seen in the room here someplace, so thank you. But when I look at it through the eyes of a bad guy, and I look at things at increasing customer expectations and the notion of increased security threats, I look at this and say, okay, this is my attack pattern. If they're making it easier for the clients to do business, either opening accounts or taking money out of the accounts, it's making it easier for me as a bad guy. So what do we do about this? Historically, this is a fraud model that I've used for years, right? And the idea is that a bad guy is going to have to come in from the top to get to, normally I have some gold chips at the bottom to show the progression. The first thing they have to do is they have to defeat your security. As a bank, you want to put up security and access controls to keep the bad guys out and know who's in. Your next level down is your policies. What are you allowing the customer to do? If I do remote deposit capture, am I allowing immediate funds? Am I getting them in the next day? Is there a cash limit? Is there a cumulative limit? So policies, and policies here are the opposite side of the coin of customer service. If I want to be an easy-to-use, frictionless bank, my policies have to be very liberal. But if I want to protect the bank, they have to be very conservative. So how I set my policies matters here. The next layer down is the process automation. I can have the policy, but if I don't put it into play from an automation perspective, I'm requiring a human to implement a policy. And we know that some of the greatest sources of fraud come from within. So you have to have automated processes to implement your policies. And so the bad guy has to traverse that entire network. Then at the bottom is where you have your counter fraud capabilities, the ability to detect fraud within real time, the response to when you've detected fraud, the discovery of fraud that is more of a retrospective review, looking for the patterns and anomalies, and then the investigation that confirms suspicions. So this ecosystem is how you defend. And if you think about this ecosystem, think about your bank, tell me how connected these layers are, right? You've got a security group over here that's setting the access controls. You've got a marketing group that's setting the policies and procedures that are basically being implemented by technology or capabilities, usually from IT. Your process automation is about your operations center in the bank and how much of that is processed. And then counter fraud is in its own little space as well. And sometimes SIU and investigations is elsewhere as well. So you have this really disconnected ecosystem that the bad guys in a digital age are just going to plow right through. So what ends up happening is you have to compress this. You have to bring the security and authentication actually down into the fraud detection so that those become synonymous. They have to be fused. They have to be tied together. And so in the past, we could keep authentication separate from transaction monitoring. Constantine's been talking a lot about the transaction monitoring. And if you looked at a couple of his slides today, he was showing how we're bringing the authentication data into that as an external data source. We have to actually go a step further and make it a more tightly coupled interactive process. So we have to use the authentication and identity management to keep the bad guys out. But with the move to digital and faster, the authentication now becomes digital. In the past, authentication usually required some physical instrument or process. Now it's your phone. Where's the authentication? How's the authority being granted in that? You don't have the fallbacks. And when you start applying that now to real-time payments where you don't have clawbacks or recoveries, you are creating a situation that's going to create a lot of exposure for the banks as this comes online. In the past, in our fraud solutions, we used what we would call second-generation solutions, or what I call second-generation solutions. There's a customer action. There's then the authentication request that usually then goes into some kind of a scoring model. It then lands in some sort of decisioning model before a decision is reached about whether or not to accept that transaction. Constantine spoke about that a few minutes ago. And then you have an alert, and then you get the feedback. There's a few problems with this. Number one is this feedback is coming into your decision rules. It's not coming back to the models. A lot of the models in fraud systems of today are second generation. They're only updated once or twice a year. And it's based on the consortium feedback, as Constantine said, that it's required to support those models. The second issue is that we're not just talking about payment transactions now. In today's digital era, we're talking about should I allow this email to be changed by the customer in their profile? What if it's an account takeover? Should I open this account? Can I trust the identity? So the aperture of decisions that we have to make now expands greater when we're in a digital era because we've now lost sort of that human or physical barrier on authentication. So we have to bring that into the equation. In third generation solutions, what we're doing is we're trying to, and I consider what Constantine was showing with Safer Payments third generation, you saw the rules generation creating those rules. We now are taking the risk assessment and bringing it in concurrent to the decisioning so that that becomes a single process. And it has to be a single process. It has to be done very quickly. And we have to be able to bring what happens from the alert process and the resolution of alerts immediately back into that entire ecosystem, not just into the decisioning side of things. If we don't do this, we don't operate fast enough and we don't respond quick enough to the threats as they emerge. And you'll notice at the bottom, this notion of profiles being added in is also incredibly important. When you're thinking about stopping fraud, really you can talk about a lot of things, but it boils down to two: understanding behaviors and understanding relationships. If I understand behaviors and I understand relationships, I can stop fraud. And profiles are what give us the historical data that we need to use for the analytics to help us determine behavior. So when you put all of this together, this is an example of what an ecosystem could look like. This is my version of your chart that marketing kind of has a little bit of an issue with. But what we're trying to show here is that in the digital model, the behaviors start when the applicant for an account tries to open an account or register an account in your digital platform. And all of that is becoming behavior. Where did it come from? How did they navigate? What was the process? And you can begin to spot behaviors that look machine-generated from human-generated, criminal-generated from good customer-generated. This becomes data. We use a model that we call sense, wait, and decide. You have sensors that is giving you the data, the expansion of the data that Constantine was talking about. The more sensors, the better. My registration system, my identity access management system, my authentication system, the web environment that's monitoring the navigation of the user through the website. All of these are sensors that are then coming into this decisioning ecosystem. where we can, number one, the yellow arrow going down, use all of that to continuously enhance the behavioral profile information. And then as we move into weighting, we can now determine, and weight is W-E-I-G-H-T, not W-A-I-T. We're trying to weight the importance of the signals that are coming in. So I'm getting these signals, how important are they? What is the risk score? This is where we sometimes would talk about scoring. But we want to look at the relationship models, we want to look at the behavior models, and we also then want to be able to create a risk score that then feeds into a decision engine that allows us to take and decide, is this a good transaction or event or a bad one, and then decide what action we're going to take. Now, you need this to be operating in the bulletproof high-speed approach that Constantin was talking about, not just for payment transactions, but again, if this is, say, an account opening process, I need to be able to have this sense, weight, decide process happen within milliseconds so I can go immediately back to my authentication engine and say, hey, this is a risky transaction, let's step up the authentication, right? Just putting in a name and ID isn't enough. Now I want to do some kind of biometric or 3D secure or these things that if you do it every time are going to alienate your customers or your potential customers. But if you do it when it's appropriate, you're going to get the right level of abandonment because you're going to get the people who you want to abandon, right? Marketing doesn't always understand that. There are customers you don't want because they're not there, to profit, add to your profits, they're there to take them. So this interactive process has to happen very quickly. And then when we bring in actual payment processing and we bring in AML transaction monitoring, we can continuously improve these behaviors. This becomes what I refer to as an intelligent risk decisioning platform. It's no longer just a payments fraud solution. This is an intelligent risk decisioning platform. If I want to manage risk in my enterprise, I'm going to be trying to make intelligent decisions. Should I open this account? Should I allow this email to change? Should I allow this transaction? Should I accept that this alert is a false positive? These are all just decisions. And the value of AI is that we can make better decisions. And so having a bulletproof, intelligent risk decisioning platform is going to be key to protecting your customers in this digital age, especially as we're seeing the bad guys using what you're creating for your customers against you. So some of the things that I've learned as I've worked with the banks and heard from the banks, it's interesting because we'll get into these conversations that basically say, well, if I just put up good authentication, I solve all my problems. I don't have a problem if I keep the bad guys out. You're not wrong with that, but it's a high-risk scenario because if any of the bad guys figure out how to get the keys, then they have free reign. And so you have to be able to fuse cyber and fraud together, both in the technology up front and the operations in the back office. You have to think ahead on these things. I can't tell you how many conversations I have after the digital channel has been introduced, whether it's on the payment side or the marketing side, that all of a sudden fraud is running rampant. Venmo had this last year in a PayPal subsidiary. If you looked last August, I think it was, they had to restate earnings and they had to turn off services because they didn't think ahead enough to protect the channel from the threats that, frankly, you don't know about, right? If you introduce a new capability, how do you know what the threats are till they present themselves? That's why the agile modeling is so important, because you have to have both the tech and the operations to respond quickly to new threats when you introduce new channels. Protection by design is the way I would call this, is thinking ahead of time to understand where are the bad guys going to take advantage of this, and how do I bring that into the design of my ecosystem rather than recover from it after the fact. And as I've said a couple times, the digitization of today's banks is creating a gold rush for the bad guys. The speed and the pace at which they can test their stolen identities, access, run their new schemes, and get results, it's the same for them as it is for any analytics process you're trying to run in the bank. The faster I can run it, the quicker I get the results, the faster I can tune it. And that's what they're doing. And the account takeover may be one of the biggest threats, because when you combine the amount of data breach and the amount of identities that are available in the dark market has created, it's supply and demand. They're very, very cheap. You can buy a large bulk of stolen identities for next to nothing, and now if I have the effective robotic process automation of a digital channel to test them, all of a sudden what used to take me, weeks now takes me minutes to take advantage of the banks. And then finally, the intelligent risk decisioning becomes a critical element. This is how we identify the behaviors and the relationships that are going to be necessary to stop fraud. Black box models just aren't going to cut it anymore. They're not nimble enough, and they're not based on your risk exposure. If you can't control the model on your own, then I'd be really questioning whether you should be using that model, because things change fast. When we're dealing with what I was just talking about with their equivalent of robotic process automation to attack you, you need the equivalent on the backside to be able to defend. 6-month, 12-month updates are just not going to cut it in the future. And then the last is applying that to all of your transactions, not just financial transactions. The non-mons are critically important, profile changes especially. So I think what Constantin was talking about with safer payments and some of the lessons that we've been learning over the years that led to its creation and now its implementation are what are going to be critical for you as you move into this digital age, keeping your customer and the bank safe. So I think that's all I have. I think we have a few minutes for some questions and some dialogue. Or not. Any comments, any reactions, any thoughts? Yes, sir.
In terms of your overall model, how does it interact with, say, digital IDs, like authenticity or verified me or whatever?
Yeah.
How does your model interact with that?
So to me, those become, if you look at the entire ecosystem, those become new sensors. Now, granted, they're giving you a score and a risk score that comes out of them, but the fact of the matter is that they're using some biometric or some other technique to give me a new signal that I can bring in to sense, weight, and decide. So I now can sense, I can weight that. Yeah, they're going to give me a score, but I want to weight that in the context of all the other information that I have, not just by itself, and then make a decision. And so in the ecosystem, the way we think about that is you want to go with the minimal amount of authentication as you can until the request creates enough risk that you need to step up. And so then we would step up and we go back to an authentication hub to basically say, okay, we got to go to level 2 or level 3 based on this risk profile, present that back to the user. They go through that biometric or one of these other sensors. Now you have another piece of data that basically comes back through the whole system. So my observation space just increased, and I can reevaluate at that point, and it'll either pass or I maybe have to step up again and say, no, you need to go to a branch and actually see somebody. We're not going to accept this risk. Does that? Okay. Other thoughts or ideas? Do you see risks like this? Yeah, go ahead, sir.
Can you shed any light on how your model changes with different types of customers? So, for example, we have retail customers.
Yeah.
You have commercial banking customers. You have wealth customers. Is there anything that you can add to help enhance our understanding in that area?
Yeah, and I think this is one of the biggest things that is different and takes a while for traditional thinking to embrace. We don't start with the model. We create the model. Right? So when we deal with the wealth customer, we look at the wealth customer's risk profile, their historical outcomes, their channels, and we basically can use the agile development that Constantin was talking about to create day one models immediately for that institution without coming in with a specific set of models. And when we respond to RFPs and get into these discussions, it's the hardest thing that I find that we have to overcome is people expect you to come with the model. And I think in the future, it has to be your model. And so each institution, you're going to essentially create a unique model for that institution based on their, if you go back to I don't know if I can go back, if you go back to this model, it's going to be based on their policies, their process automation, their ability to detect fraud is going to influence the risks that entity sees. So there's not a single black box model that tries to cover everybody. You actually create the model uniquely. And with the data science revolution and the power of computing and the tools and the data, that's not an impossible task. 20 years ago, it might have been. Today, not so much. And so the thing is, my role in services is producing business outcomes. The thing I like about something like the safer payment solution is that I can use it as a tool to create my own risk model. I don't have to be dependent on somebody else's. So to answer your question a little bit differently.
Fair enough, yeah.
Yeah. Okay. But to me, that's one of the big differences between second generation and third generation. We're going to see more of the ability to rapidly create unique individual models.
Yeah, I would go as far as saying that the days and ages of the outsourced model generations are over. This is just not fast enough anymore. If you run payments processing and you also have the responsibility for the fraud prevention function, you need your own people who understand the fraud patterns that you are attacked with. You need them in-house when you are under attack to work with all the tools to create and adapt the models to protect you from that. You cannot expect this from outsourcing this to somebody who's giving you a new model every quarter or even only every year.
Yeah, the way I describe it is we're not using AI to be the model, we're using AI to create the model. And,
Yeah.
and that's a big shift.
Are you talking about the individuals and the intellectual property, the knowledge in-house? So when you say you need it in-house, do you need on-prem in-house type deployments, or is it just the team itself needs to be part of the institution?
Well, not necessarily on-prem, meaning that these solutions couldn't be hosted. I mean, for example, most of the processing in cards is of all the issuers is not necessarily done in the data centers of the banks. They use processes such as TSYS, Fiserv, FIS, First Data to do that for them. But these processors provide, ideally, the tools that they may create sort of a general fraud model for you, which may be good enough for most of the cases, but still, if you have access to these systems, which some of these processors provide their customers with, if you are under, some fraud attacks can be very individual, and these are the painful ones. And if you have the capabilities of controlling a little bit your own destiny, and you are able to also adopt certain parts, at least, of the model to protect you against such episodic fraud, then you'll be very happy that you have done that.
One thing to clarify too that is also, and I put this chart back up, is historically we've used the term model in our business to refer to the statistical model. The risk scoring model, the mathematical model. In third generation, the model is all of the items that come together in order to make a decision, a risk decision. So it includes the relevant data, it includes the profiles, it includes any statistical scoring that you're incorporating into the model, but it also includes the risk assessment rules, the decisioning rules, and the action rules. This becomes the model. So the model is not just a statistical model when we use that term. It's actually the decisioning model and everything that's required to render a good decision.
Okay. In this case, let us thank you very much for your time here. If you would like to continue the discussion, down there in the exhibit hall, there is this blue thing, IBM there, and we'll be close by and love to further discuss with you. Thank you all very much.
Thank you.